I wanted to give you just a little bit more review on that. These are the equations that we have learned to use so far in this class. We know how to use Kirchhoff's laws. There are two of them. They can be used separately or together. In each of these cases, the arrows on the left are telling us the input information, and the arrows on the right are telling us the output information. The boxes in between are equations that I'm assuming that you already know from the class. For example, in Kirchhoff's voltage law, we know that the summation of voltage differences, that's what the delta means, voltage difference around a loop, is equal to 0. Kirchhoff's current law, we know that the sum of incoming currents is equal to the sum of the outgoing currents, and these are the branch currents. So if we knew, for example, our voltage source, our current, and our resistance, we could calculate voltage differences around the loops. If we knew the incoming and the outgoing current, we could find the outgoing current. If we knew the outgoing current, we could find the ingoing current. If we combine these, if we do a series of loops plus at least one node, we can take in our sources, our current and our voltage sources, and our resistance, and we can find the branch currents. Resistors in series and parallel are simply used to combine many resistors into a simpler one. Voltage dividers are used to start with our source voltage and resistance and find voltage difference. Current dividers are used to start with our current source, our resistance, which we convert to G, convert R to G. Remember that G is equal to 1 over R, and that gives us the output branch current. The Ohm's law equation, we use current. So suppose, for example, that we know a voltage difference and a current, we can get resistance. If we know a voltage difference and resistance, we can get current. If we know current and resistance, we can get voltage difference. Tell this thing to go away. Okay, the power equation, if we know voltage difference and current, we can get power. If we know voltage difference and resistance, we can get power. And current and resistance, we can also get power. This equation is telling us about node voltages. This is the only card that we have that talks about node voltages, so this is the only way we can find them. If we know one node voltage and voltage difference, we can find all the other nodes. If we know two node voltages, we can find the voltage difference. Or if we know one node voltage and I and R, we can find all the other nodes. So let's just see a little bit about a couple of these cards. I would particularly like to talk about how to use this card right here if we have voltage differences. What you do is you line up this current with the current in your circuit, and then you can see the two nodes on either side, and you use this equation right here. Voltage difference, or the VA minus VB. So this is our electrical engineering toolbox. We have Kirchhoff's laws, we have node voltage equations, we have Ohm's law, which tells us about difference voltages, the power, which uses voltage and current to get power, this method of combining resistors in series and parallel to simplify them, voltage dividers that use the source voltage and resistance to get voltage difference, current divider that uses the source difference and conductance in order to get current through each branch. We can combine these by looking at what comes in on the left and what goes out on the right. What I do usually is I take all of the things that I know and I put them on the left, and I put the things that I want on the right, and then I make myself a track so that I can follow through from left to right until I'm able to solve the problem. For example, the problem that we just did, we had Kirchhoff's law that it gave us current. We then used our current and our resistance to find our voltage difference, and we used our voltage difference and one node to be able to find all of the other node voltages. Other things we might have done is we might have first combined resistors in series and parallel in order to make this simpler over here. So we could have used this one first, and sometimes we might use voltage dividers in place of Kirchhoff's laws, or current dividers in place of Kirchhoff's laws. So we can use these particular sets of equations to be able to solve for the voltages and currents in our circuit. In the next section of the class, what we're going to do is add a few more tools. Particularly, we're going to add node voltage equations that often replace our Kirchhoff's laws.